An Outline Theory of Dialectics, Chapter 5 Connection and Development as the Main Principles of Dialectics. 1. On the universal connections and interactions, the concepts of connection and relation. The philosophical principle of universal connection. The entire reality accessible to us is an aggregate of objects and phenomena linked with one another by extremely diverse relations and connections. All objects and events are links in an infinite chain joining all that exists in the world in a single whole, a chain that is, at its deep-lying basis, nowhere disrupted. Although matter is discrete, everything interacts with everything else. The bond uniting all objects and processes in a single whole is universal in character. The life of the world is in the endless web of relations and connections. They are the threads, as it were, that fasten everything. The moment they are broken, everything will disintegrate into chaos. The principle of relation and connection is an adequate reflection of the organization of all that is, and of the systems forming it. One of the fundamental worldview and methodological principles on which the entire categorical edifice of philosophy is built. It expresses the materiality of reality, the condition of the connection of everything with everything, including the various forms of the motion of matter. In other words, this principle rests on the material unity of the world. Connection is usually defined as a deep-seated attributive property of matter, consisting in the fact that all objects and phenomena are linked by infinitely varied interdependence and various relations with each other. In other words, connection is a general expression of dependence among phenomena, a reflection of the interdependence of their existence and development. As for relation, it is mostly defined as one of the forms of, or an element in, the universal interconnection of objects and processes. Indeed, everything exists in two hypostases, as it were, as being by itself and as being for others, in relation to these others. The existing relations are extremely varied. They are the relations of equality and inequality, of subordination and coordination, of part and whole, etc. The kinds of relations listed here are universal in character, concealing, as it were, the deep substantive connection of phenomena. Thus the part and whole relation expresses the functional connection. Of all the kinds of relations, the most universal in character is the relation of dependence, for even that which at first sight appears independent from the environment, in the final analysis proves dependent on it. This environment, being indifferent to something that is apparently independent, exerts, in one way or another, through its development or change, a direct or mediated influence on it, being a direct or mediated cause of change in its state. Along with the diverse relations, there are the extremely varied types and kinds of connections. The types of connections are defined in relation to the level of organization of matter. Related to the different forms of the motion of matter, there exist in inorganic nature mechanical, physical and chemical connections presupposing interaction either through various fields or through direct contact. In the ensemble of atoms forming a crystal, a separate atom cannot oscillate independently, the least of its displacements affects all others. The particles of a solid body can only oscillate collectively. There are also more complex connections in living nature, biological ones, which are expressed in the relations of elements within an organism, within a species, and among species, as well as in their relations with the environment. In social life, the connections become even more complex, forming production, distribution, class, family, interpersonal, national, state, and other types of relations. However, connections exist not only among objects within a given form of the motion of matter but also among all its forms. For example, there is a connection between attraction and repulsion in the inorganic world. In society, the same connection acts in a complex mediated form, being subordinated to the social laws of people's life and therefore transformed into a different quality, such as sympathy and antipathy, interpersonal compatibility and incompatibility. Besides, there exist such forms of connections as external and internal ones, direct and mediated, functional and genetic, spatial and temporal, law-governed and accidental, cause and effect, and so on. These forms of connections are differentiated depending on the aspect of consideration of the objects under study. Thus the human organism may be considered in terms of functional connections, genetic connections, or internal and external ones. The connections may be one-sided, two-sided and many-sided. The functional connection is, for instance, a many-sided one, while the genetic connection is unisided, developing always from the past to the future. Any form of connection always has its definite basis, which makes it either necessary or accidental, constant or temporary. The basis is an essential objective condition ensuring the formation and existence of a given connection. Thus the gravitational properties of systems condition the force connection among cosmic objects. Atomic nuclear charge is a connection in the periodic system of the elements. Needs and interests form the basis of interconnections among people in society. Through his activity, man mediates the connections and relations, existing in nature, among objects and processes. His impact on nature is often negative in its more remote consequences, as man is not always capable of taking into account all the connections and relations existing in nature, stressing only those of them which have a direct bearing on the goals of his activity. In other words, consciously or unconsciously, man violates in these cases the universal interconnectedness of phenomena and processes. For example, forest cutting reduces the bird population and that, in its turn, increases the number of agricultural pests. Destruction of forests sands up rivers, erodes the soil and thus leads to a reduction in harvests. There is nothing in the world that would be unconnected with the whole. Evidence of experience may appear before us only in isolated form, and our mind can point to isolated facts only, but that does not mean that they actually exist in isolation. The whole point is to discover a method for identifying the connection between these phenomena and the nature of such a connection. The concept of connection is one of the central concepts in dialectical materialism. It is used to substantiate the principles of development, of the struggle of opposites and interrelation between quantitative and qualitative changes, etc. The concept of interaction is a further clarification of the principle of universal connection. The concept of interaction. Everything that happens in the world springs from constant interaction between objects. Because of the universality of interaction, all the structural levels of being are interconnected, and the material world is unified. This interaction determines the emergence and development of the objects, their transition from one qualitative state to another. Interaction is a philosophical category reflecting the processes of reciprocal influence of objects on one another, their mutual conditioning, changes of state, mutual transition into one another, as well as generation of one object by another. The dynamics of the cause and effect conditioning of motion, of change and development in nature, society and thought presupposes heterogeneity and diversity of the forms of manifestation of all that is, the incorporation of each fragment of being in the stream of universal interaction. Interaction is objective, universal and active in character. The properties of an object can be manifested and cognized only in interaction with other objects. Reciprocal action is the first thing that we encounter when we consider matter in motion. One underlying each form of the motion of matter are definite types of interaction, which acts in them as the integrating factor through which parts are united in a definite type of a whole. For example, the electromagnetic interaction between the nucleus and the electrons creates the structure of the atom, while informational interaction among human beings creates one of the principal constituents of social life. The category of interaction is an important logico-methodological and epistemological principle of the study of natural and social phenomena. Modern natural science has shown that any interaction is connected with material fields and is accompanied by transference of matter, motion and information. The existing classifications of interactions are based on the differentiation between force interactions and informational interactions. In physics, four principal types of force interaction are known: gravitation, electromagnetism, and weak and strong interactions. They provide a key to an understanding of an infinite variety of processes. Each type of interaction in physics is characterized by a definite measure. Biology studies energy and informational interactions at various levels: molecular, cellular, organism, population, species, biogenosis. Even more complex interactions are found in the life of society. for society is the process and product of people's interaction with nature and among themselves. People's spiritual world is organized through semantic, psychological, logical, moral, aesthetic, and other interactions. The interactions in the social sphere are realized not only in closed social systems, but also within mankind as a whole. And that makes the optimization of social interaction necessary as well as possible. The course of history, social progress, insistently demands the establishment of constructive and creative 1 F. Engels, Dialectics of Nature, in K. Marx, F. Engels, Collected Works, Volume 25, p. 511. Interaction between the peoples on a planetary scale, creating the necessary premises for that, political, social and material. Without a study of interaction in its general and concrete manifestations, it is impossible to understand either the properties or the structure or the laws of reality. It is in the process of interaction that the essence of interacting objects and their properties are realized. That is why knowledge of things means cognition of their interaction and is itself a result of interaction between subject and object, for no phenomenon can be explained by itself. 1 Contradiction, or interaction of opposites, proves to be the deepest source, the basis, and the ultimate cause of the emergence, self-motion and development of objects. Without clarifying the forms and content of various kinds of connection and interaction in nature and society, it would be impossible to handle adequately the problem of development, which is the second fundamental principle of materialist dialectics. 2. The idea of development and the principle of historism. The general conception of development. Application of the principle of universal connection and interaction results in a specific and universal category of dialectics, the category of development. There is nothing ultimately complete in the world, everything is on the path towards something else. A given type of connections and interactions determines a definite direction of this path, where from and where to. The principle of the motion of matter as a mode of its existence, combined with the principle of universal connection, gives a general idea of the development of the world. Development is an irreversible, definitely oriented and law-governed change of material and ideal objects resulting in the emergence of new qualities. The swinging of the pendulum is an example of motion, while the growth of a child is an instance of development. Let us consider, one by one, all the 4 distinguishing features of development indicated here. What does irreversible change mean? It means that in the process of development, as distinct from the cyclical functioning of a system, return to already past states is impossible. Everything passes through one and the same state only once. Thus the movement of an organism from old age to youth is impossible. This won the wisdom of Goethe. An Anthology, Carlton House, New York, S.A., pages 166. Example shows already the direction of development. Therefore the next characteristic, definitely oriented change, means that changes of the same quality are gradually accumulated in the process of development, being determined by the type of interaction of the given object with the surrounding world and by its inner contradictions. The sum total of such changes determines the line of the object's directed change. For example, the sum total of qualitatively similar methods of processing a given material or substance, rare and isolated at the beginning, results in the final analysis in the formation of a new technology, changing the qualitative definiteness of labor accordingly. And what does law-governed change mean? It means that underlying development are not accidental events, of which the infinite numbers disturb the object's oriented change, but rather the necessary events that follow from the very essence of the object and from the type of its interactions with the surrounding world. However rich in all kinds of random events the history of the ancient world might be, all the fountainheads of civilization known to science passed through the stage of gentile and tribal organization or feudalism. All 3 features of development pointed out here inevitably draw attention to the 4th trait, emergence of new qualities, which are, as it were, a definite summing up of the previous development and the starting moment of the subsequent one. Progressive development is thus thought of not as movement of some object from one point to another but as a process which, at each subsequent stage of its further movement, raises higher and higher the whole mass of already attained content and, far from losing something essential, carries with it all that it has accumulated, bringing in new content. The new is an intermediate or final result of development correlated with the old. The changes may pertain to the composition of an object, that is to the qualitative and quantitative characteristics of its components, to the mode of the connection between the elements of the given whole, to the function or behavior of the object, to the character of the object's interactions with a different object, and finally to all these characteristics as a whole. Development is a dual process. The old departs and the new comes in, asserting itself in the struggle against the old rather than through unhampered unfolding of its potential. The relationship between the concepts of development and progress must be clearly understood. They are close to each other but not identical. Development results in the appearance of a new quality, but it is not at all necessary that this quality should be more complex or more perfect than the previous one. If the new quality is in some respect superior to the old one, we have a progressive tendency of development, and if it is inferior, we have a regressive tendency. Thus the aging of an organism is a regressive tendency of development, which may be accompanied, though not always, by a progressive tendency in the development of the individual's spiritual and intellectual potential. Regress is just as irreversible as progress, that is to say, a new quality may appear at any stage in regress which is irreducible to the previous states. Being just one of the tendencies in the development of life, regress is by no means linked with degeneration or extinction. Regressive simplification of the morphophysiological qualities of a given biological species is often linked with the needs of adjustment to a new environment, and many of the so-called degenerated forms belong among the most flourishing groups of the animal world. Progress and regress are two different tendencies of development which, however, are intertwined with one another, forming a complex interdependence. In complex systems, one element or level may be subject to regress while the system as a whole may progress, or, on the contrary, a general regress of the system may be accompanied by progressive development of its separate elements. If we consider the larger scales of development, such as organic evolution, interaction of differently oriented processes is distinctly discernible there. The general line of progressive development is interwoven with changes that give rise to the so-called blind alleys of evolution or even paths of regress. Having great heuristic force, the idea of development has significantly enriched the worldview and methodological principles of science. The branch of progressive development known to science includes the pre-stellar, the stellar, the planetary, the biological and the social stages of the structural organization of matter. On the cosmic scale, the processes of progressive and regressive development are apparently equal in their significance, since both result in the emergence of new forms. Cyclic processes also figure prominently in the universe, cf. the transmutation of elementary particles. Progress and regress actually coexist in objective reality, as do deformation, decay, revolutionary, leap-like, and evolutionary changes, spiral and cyclical material processes, that is there coexist two opposing directions of development, along the ascending and the descending line. Development along the ascending line is development from the elementary towards the complex, more perfect, more finely organized, towards a richer potential and greater information volume, a process in which the structure becomes more refined, matter and energy accumulate, and the extent of coded information grows. Descending development is the path of decay, degeneration, impoverishment and decomposition. Wisdom has learned from being that these processes do not run separately but are combined in different proportions. In some cases the ascending element prevails, and progress occurs, while in others regress and the descending line predominate. However, the prevailing general tendency is progressive development, for cyclical development and decay are mostly characteristic of separate objects and processes of the material world, while on the whole the unstoppable and irreversible movement accompanied by the emergence of ever new forms is indubitably universal. Development and time. The crucial feature of development is time. Development takes place in time, and only time brings out its direction and irreversibility. The history of the concept of development as emergence of new forms goes back to the formation of the theoretical notions of the direction and irreversibility of time. The ancient cultures had no knowledge of development in the true sense. Time was thought of as flowing cyclically, and all events were perceived as mere repetition of the old according to the decrees of fate. The idea of cyclicity could be expressed like this: the sun also ariseth, and the sun goeth down, and hasteth to his place where he arose. The wind goeth toward the south, and turneth about unto the north. It whirleth about continually, and the wind returneth again according to his circuits. The thing that hath been, it is that which shall be. And that which is done is that which shall be done. And there is no new thing under the sun. 1. The idea of the perfect cosmos underlying the ancient view of the world ruled out the very question of the direction and irreversibility of time, and of changes which could give rise to new systems and connections. Development was interpreted as the unfolding of certain possibilities inherent in things and merely hidden in them. The ideas of the irreversibility of time and its linear direction emerged with the assertion of Christianity, and that only in the sphere of human being. Only later, with the formation of experimental science, were these notions gradually extended to the study of nature. 1 Nicholas 1:5-6-9. The ideas of natural history, of oriented and irreversible changes not only in nature but also in society, gradually emerged. The French natural scientist Georges Louis Buffon published his Histoire naturelle, in which he attempted to present the development of the earth, the animal world and man as a single evolutionary process. For those times, it was a daring step, for everything was then regarded as immutable since the day of creation. Immanuel Kant published his work General History of Nature and Theory of the Heavens, which substantiated the view of the Earth and of the solar system as having evolved in time, and proposed the hypothesis of the emergence of planets from a primordial dust nebula. The turning point here was the creation of cosmology and the theory of evolution in biology, Lamarck, Goethe, Darwin, and geology, Lyell. The idea of development and the historical thought that sprang from it became part and parcel of natural science and philosophy. Historical thought moved into the foreground among other methodological principles in the 19th century, which will go down in history as the age of historism. In those times there was not a single natural, humanitarian or philosophical science that would not reflect, in one way or another, the historical type of thought, cf. comparative historical linguistics, the doctrines of political economy, etc. But the triumph of historical thought, based on the concept of linearly unfolding, oriented and irreversible time, and thus on the category of development, came with the Marxist principle of historism. The principle of historism in a general methodological interpretation. In Marxism, the principle of historism has a universal methodological significance. The essence of this principle, in brief, is not to forget the underlying historical connection, to examine every question from the standpoint of how the given phenomenon arose in history and what were the principal stages in its development, and, from the standpoint of its development, to examine what it has become today. 1. The distinctive feature of Marxist historism is that, embracing all the spheres of reality, it agrees with the monist principle of the material unity of the world. The idea of historism had different forms. In ancient philosophy it took the form of the idea of becoming, the birth of possibilities. 1 V.I. Lenin, The State, Collected Works, Volume 29, Progress Publishers, Moscow, 1977, pages 473. And realization of one of them. Among the first to express that idea was Heraclitus, who conceived the world as constantly becoming. However, before the idea of historism found a more or less scientific form of expression, it was deeply rooted in mythological thought, in which even the gods were not something eternally given but were born, struggled through life, and died. Later, the principle of historism assumed the form of evolutionism, clearly expressed in Kant's theory of the formation of the solar system out of a primordial nebula. Before him, physics, cosmology, and astronomy were dominated by the Newtonian mechanistic conception of the universe, which assumed a nature already evolved, equal and invariable in all its parts. The idea of development was thus inherently alien to the Newtonian paradigm. A similar picture was observed in biology. It was presented in accomplished form in Carolus Linnaeus' system of binomial nomenclature. The fundamental feature of the method of thinking in natural science in those times can thus be summed up: nothing can emerge apart from that which already exists. Kant highly valued physics and its possibilities in the explanation of natural phenomena, but he was not satisfied with a simple description of nature, believing that its true interpretation was impossible without the idea of genesis. He was the first to introduce the idea of evolution in the understanding not only of the physical world but also of the living one. From the moment of the assertion of historical thought in the 19th century, the debate has never ceased about the essence of the process of development, and of its motive forces. Metaphysical theories challenge the very essential content of development, the emergence of new qualities. Development is interpreted as mere growth or decrease of a quality or as repetition of it, so that the problem of contradiction as the source of development is eliminated. In biology, this tendency was manifested in the theory of preformation, which reduced the development of an organism to mere unfolding or ripening of given hereditary properties. This approach was overcome in biology by the beginning of the 20th century. The epigenetic theory, which evolved in opposition to preformation, rejected innate cognitive structures, but it also threw out the child with the dirty water, completely giving up the idea of biological development as the unfolding of innate genetic, hereditary informational structures. The idea of qualitatively new formations was unambiguously associated with the action of factors external to the given organism. In other words, if the first theory raised to an absolute the role of the inner factors of development, ignoring the significance of the external factors, the second, on the contrary, exaggerated the importance of the external factors, and underestimated the role of the inner ones. Hence both theories proved to be essentially metaphysical. Rejecting internal contradictions as the source of development, metaphysics cannot find in matter itself the true causes for this process and therefore often resorts to supernatural forces. The dialectical conception, on the other hand, primarily stresses the source of self-motion and self-development. The first conception is lifeless, pale and dry. The second is living. The second alone furnishes the key to the self-movement of everything existing. It alone furnishes the key to the leaps, to the break in continuity, to the transformation into the opposite, to the destruction of the old and the emergence of the new. 1. There is nothing mysterious about the concept of self-motion. It merely means that the source of development is inherent in the developing object itself, which interacts with others. The development of any system is realization of the universal principle of being, the activeness and inner striving of all that is towards self-expression in infinite forms of interaction. Development is a form of motion, and the latter is an attribute of matter, a mode of its existence, inherent in it and not inferred from anything. The self-motion of matter on the whole is not conditioned by any external factors, while the self-motion of the concrete forms and kinds of matter is conditioned by internal and external causes. If the self-motion of matter is absolute, the self-motion of concrete systems is relative. The higher the level of the organization of a system, the greater its independence in behavior, and consequently in its development. For example, primitive society depended to a much greater extent on the elements of nature than modern society. In the socio-political and philosophical terminology, metaphysical theories like biological preformation came to be known as trivial evolutionism, with its conception of development in which the new is largely a quantitative modification of the old, so that the new does not assume a complete disappearance of the old, as in the dialectical interpretation. Trivial evolutionism naturally implies rejection of qualitative leaps in development. In the socio-political sphere, for example, this stance is expressed in the rejection of revolutions. 1 V.I. Lenin, On the Question of Dialectics, Collected Works, Volume 38, pages 358. One of the most influential Western theories of development, which ultimately goes back to metaphysical evolutionism, is Henry Bergson's conception of creative evolution. Challenging Herbert Spencer's trivial evolutionism, Bergson insisted on the conception of development as emergence of qualitatively new formations rather than as displacement or redistribution of particles in space. However, Bergson saw the source of qualitative development in the idealist principle of élan vital, which means, on the philosophical plane, a need for creativity, hence the name of the doctrine, attributed to such an ideal object as consciousness or better say, superconsciousness. Accordingly, the source of development was conceived as an ideal force and placed outside the developing material object. In biology, creative evolution was paralleled by emergent evolution. Its creator Conway Lloyd Morgan, the biologist and philosopher, asserted that, along with quality-less resultative changes that are a mere algebraic sum of the original constituents, a sum that can be computed, there are also qualitative changes, but these are unpredictable. Far from taking into account dialectical laws, on the transition of quantitative changes into qualitative ones, or on the negation of negation, the theory of emergent evolution actually eliminates from science the very concept of objective law, which brings this conception close to metaphysics and agnosticism. There can be no question here of oriented or law-governed change or, in general, of any tendencies of development. Science ceases to be a generalizing and explicative activity of human reason, becoming a mere accumulation of empirical facts and their belated classification. Metaphysical views became especially widespread in explanations of the life of society. According to a current theory, society develops in an evolutionary manner, and only such development is normal. This evolution, though, leaves no room for qualitative leaps rejecting old states. Revolutionary transitions are said to be deviations from norm, and diseases of society. Metaphysical, one-sided, and just as erroneous is the opposite view, based on the emergent evolution theory, that nature's life develops exclusively through unpredictable catastrophes, and that social upheavals do not require lengthy preparation, that they are spontaneous and cannot be foreseen. The category of development and the principle of historism have a great worldview and methodological significance. A correct understanding of the history of becoming helps to understand the essence of the developed phenomenon and to foresee, at least partly, its perspective. At the same time, as we go deeper into the object's present state, we also see its past in a new light. Dialectical development is characterized by consistency, direction, irreversibility, innovations, negation, preservation of the results attained, and continuity. The principle of historism in the social interpretation. Applying the principle of historism to society, we can say that social history has the following features. First, it is characterized by a law-governed, irreversible, and oriented development, that is by the unending emergence of qualitatively new social structures and systems. Second, despite all the diverse phenomena superimposed on one another, social development is dominated by the progressive tendency. Third, the source and motive force of social development is the struggle of internal contradictions at each given stage of history. Besides, the principle of historism is important in that it links together all the three times of the historical existence of mankind, the past, the present, and the future, and most importantly, it actualizes the past and the future in the present, without which a conscious, goal-directed, socio-historical practice and people's cognitive activity are impossible. This principle, unfolded in the aspects that we have pointed out, is the foundation of the new system of philosophical knowledge worked out in dialectical materialism, the social philosophy of Marxism. The ideas of historism as a methodological principle in the study of social life were contained already in the works of pre-Marxian thinkers, most notably in Hegel's philosophy. It was Hegel who was the first to reveal the all-sidedness of development and the inner cohesion of history. However, before Marxism, social development was not explained as the struggle of internal contradictions, and the principle of historism in social knowledge was often replaced by relativism or finalism, that is the doctrine of the finality of history. What does the principle of historism contribute to an understanding of social phenomena and society as a whole? In the first place, it permits to objectively evaluate the relative integrity or completeness of a given stage in society's historical development, and on this basis to predict the tendencies and perspectives by identifying the internal contradictions inherent in it. It further helps to work out specific measures for the attainment of certain goals of social development, and to present society's further movement as a consciously controlled process. In other words, in order to evaluate the degree of development of a certain state in the present, it is necessary to know the past well, and to judge it correctly, without distortions, For ignorance of the past adversely affects knowledge of the present and jeopardizes any attempt to act in a historically promising way. It is a profound error to assume that the present is in no way determined, directly or indirectly, by the past. But society's historical ascendance is threatened by another and just as great danger, the dogmatic approach to the past, the ossification of social-moral values and judgments which leads to uncritical acceptance of evil as good. A historically self-critical attitude of social consciousness is a decisive condition of an objective, rather than metaphysically one-sided, conception by a people of its real role in world history. Distorting the view of the people's place in history and making this place an eternal absolute, historical complacency is incapable either of seeing anything historically significant in other societies or of adequately correlating itself with them. Deep penetration into the dialectics of the present and its objective logic, an ability to draw correct conclusions reflecting the flow of time, that is what is necessary above all. A historically oriented mind takes great interest in tracing and noticing everything that emerges, since an understanding of the beginning helps to find the key to the explanation of the essence of facts and events, for it always points not only to the phenomenon itself but also to those conditions which gave rise to it. This leads to an ability to see those internal contradictions in social development which, just as everywhere, are the real source and starting point of all movement. 3. The principle of causality and objective goal-directedness. The concept of causality in its relation to the principles of universal connection and development. The concepts of cause and effect arise on the borderline between the principles of universal connection and development. On the one hand, causality is defined, in terms of the principle of universal connection, as one of the types of connections, namely as genetic connectedness of all phenomena, in which one phenomenon, the cause, gives rise, under definite conditions, to another, the effect or consequence. On the other hand, from the standpoint of the principle of development, causality is defined as follows: any change, to say nothing of development, that is change towards a new quality, has its cause and consequence. It should be particularly stressed that causal relations are present not only in the process of development but also in the degradation and decay, and generally in all changes or transformations of the world, both natural and produced in a purposive fashion by men. Limitations on the validity of the principle of causality are not imposed by the principle of development, any development being causally conditioned, but by the principle of universal connection. Not all connections are causal. Among the connections that do not have cause and effect content are spatio-temporal correlations, functional dependences, the symmetry relation, etc. That does not mean, however, that there is even one phenomenon that would not have its cause and its effect. An event or fact that stands to another in the relations of, say, functional dependence or symmetry, is necessarily linked with some other phenomenon by a causal link. Causality is universal. There are no phenomena in the world that would not produce some consequences or other, or that would not be produced by other phenomena. Putting it figuratively, there is nothing in the world but parents and children. A cause may be either a circumstance external with respect to the given phenomenon or its internal contradiction. When thought begins to move from one step of causation to another, aspiring to find the very first cause, it dissolves in the infinite distances of universal interaction. Causality and time. One of the fundamental characteristics of causality is its organic bond with the category of time. Time is the form of the existence of matter in which cause and effect connections are realized most naturally. That is why the greater complexity of our ideas of time, connected with a deeper knowledge of the material world, must be reflected in our understanding of causality. However, even now the temporal aspect of the cause and effect connection is still interpreted in different ways. Some believe that the cause always precedes the consequence. There is a definite interval or delay between the beginning of the action of a cause, say, interaction between two systems, and the appearance of its consequence. For a while, cause and effect coexist, and then the cause goes out, while the consequence ultimately becomes a new cause, and all this is repeated ad infinitum. Others insist that the intervals are partially superimposed one upon another. According to another view, cause and effect are always strictly simultaneous. The reasoning here is this: it is meaningless to speak of a cause that exists, and therefore acts, if its consequence has not yet entered the sphere of being. Indeed, can there be an inactive cause? But the concepts of cause and effect are equally used to describe simultaneously occurring events, phenomena that are adjacent in time, and phenomena whose consequences emerge in the framework of the cause. Besides, cause and effect are sometimes described as phenomena which are divided by a time interval and interconnected through the mediation of several other links in the chain. Thus sun flares are the cause of magnetic storms on Earth and of subsequent disruption of radio reception. The mediated connection between cause and effect can be expressed in this formula: if A is the cause of B, and is the cause of C, A can also be regarded as the cause of C. Changing, the cause of a phenomenon is retained in its result. A consequence may have several causes, some of which are necessary, others accidental. An essential feature of causality is the continuity of cause and effect connections. The chain of causal connections has neither beginning nor end. It is impossible to say where that chain began and where it is going to end. It is infinite as the universe itself. There is neither a first, that is causeless, cause, nor a last, that is inconsequential, effect. Accepting a first cause would mean violating the law of conservation of matter and motion. Any attempts to find an absolutely first or an absolutely last cause is a vain undertaking of which the psychological basis is a belief in miracles. Despite the great diversity of the structural organization of the world, all types of temporal relations are characterized by duration, which signifies either direct sequence of events or contiguity of moments or states replacing one another. Time has duration, it is irreversible and asymmetrical, and cause and effect relations are asymmetrical too. The idea of non-uniformity of time cycles does not affect the essence of the matter. In any material system which exists and develops in its own time scale, relations may be quite unlike any other, but they are still causal. Causality and interaction. Causality cannot be considered as unidirectional action from cause to effect, for it is the inner content not only of connection but also of interaction of phenomena. Interaction, one of those types of connection which also has temporal duration, greatly complicates cause and effect relations. A consequence extends the tentacles of its influence not only forwards, as a new cause giving rise to a new effect, but also, in a definite temporal perspective, backwards, towards the cause producing it, modifying, exhausting or augmenting its force, especially in those cases when the causal connection is continuous and extended rather than instantaneous and discrete. This interaction between cause and effect extended in time is called the feedback principle. It operates everywhere, especially in all the self-organizing systems, in which information is received, stored, processed or used, as for example in the living organism, cybernetic device, or society. Stability, control or progressive development of a system are inconceivable without feedback, which regulates cause and effect relations. Only in the simplest particular case, and an extreme one, can cause and effect connection be represented as a one-sided and unidirectional action. In complex situations, it is impossible to ignore the reverse, and secondary, in terms of time, effect of the carrier of action on other bodies interacting with it, which is connected with the complex discrete continuous structure of matter and changes in temporal rhythms. Thus interaction between cause and effect in feedback in cybernetic devices results in this effect becoming itself a cause in relation to the cause that produced it. Cause and effect may change places, but the temporal direction of the process of causation remains immutable. Psychological processes are also a result of extended and alternating interaction between the surrounding world and the cortex. Thus no cause and effect processes in the world are produced by one-sided actions. They are based on the relation between at least two interacting objects, and causality must in this sense be regarded as a type of interaction, not just as a kind of connection. Metaphysical theories cover only one aspect of causal dependence, from cause to effect. On the basis of this interpretation, it is impossible to explain the principle of self-motion of matter, which always figures as interaction. Combining causality and interaction leads to the real causal relation, one that does not contradict the principle of self-motion of matter. Cause and effect are separate links or different aspects of the process of universal interaction. The identification of one rigidly determined cause and effect link is always an abstraction from the multiform world of the real cause and effect interactions, which is, undoubtedly, a convenient but at the same time arbitrary cognitive procedure. The world of real interactions is incomparably richer than any abstractions. Different causes may lead to an identical consequence, just as different paths may lead to one and the same place. Then again, one and the same cause may produce different consequences. A cause does not act with absolute determination if only because its result depends not only on its essence but also on one F. Engels, Dialectics of Nature, in K. Marx, F. Engels, Collected Works, Volume 25, pages 512. The character of the phenomenon at which its action is directed: strong heat will melt wax but it will temper steel. At the same time, the heat effect is produced by various causes: the action of sun rays, friction, mechanical blows, chemical reactions, electricity, nuclear fission, etc. There are no phenomena in the world which would result from one cause only, and which would not be affected by secondary causes. If that were not so, pure necessities above would be possible, and that would mean a world ruled by fate. Types of cause and effect relations. Classification of the types of causality is a highly complex scientific problem. At present, there are several such classifications, all based on different criteria. One such criterion is the inner substantial content of the processes of causation. The inner mechanism of causation is necessarily connected with transference of matter, energy, and information. Thus the birth of a living organism is connected with transference of matter, energy and information. In the collision of billiard balls, the mechanical energy of the striking balls is transferred. In social control, the information cause prevails at its semantic level. In this type of classification of causes, the causes usually identified are material and ideal, informational and energy, and these, in their turn, are subdivided, in relation to the kinds of the motion of matter, into physical, chemical, biological, psychological, and social causes. The causal connection differs from other, non-energy types of connections, putting it broadly, in this feature of necessary transference of some qualities pertaining to matter or energy. The cause and condition of an event are also distinguished on this criterion. A cause is something that passes on to something else its force potential, that is matter, energy and information, while a condition is the sum total of the circumstances of a causal event which, not being themselves a direct cause, and taking no part in the transference of matter, energy or information, contribute to the production of a consequence by a cause. Thus if a patient dies in the absence of timely medical aid, the cause of the death is the disease, while the absence of medical aid is a condition of death but not its cause. The second type of classification of cause and effect relations is based on the modes of manifestation of the causal link. These modes are subdivided into dynamic, single-valued, and statistical, probabilistic. Thus all the laws of quantum mechanics or of informational interactions in society are probabilistic in character. Their inner content is strictly determined by their direct cause, but at the 136th same time the mode of manifestation of this causal link depends on a great many accidental factors characterized by a certain statistical frequency. In metaphysical theories, the probabilistic form of manifestation of a causal dependence is often associated with negation of the principle of causality itself. Probability is identified here with absence of causality. This interpretation, however, indicates a lack of discrimination between the inner content of causation and the modes of its realization. Externally, the same content may be manifested both in a dynamic and in a statistical form. Despite the fact that causality may be realized in different, dynamic or statistical, forms, it does not become chance or absence of any causes at all. Thus the fact itself of the appearance of a given personality at a given crucial period in history is statistical probabilistic, but the connection between the necessity of the appearance of precisely this type of historical figure, with given general features, and its actual appearance, is in the nature of cause and effect. The identification of this kind of statistical probabilistic laws makes it possible to reveal the chain of cause and effect connections which force their way through the total action of a great many chance occurrences. However accidental the fact of the birth of a boy or girl in a given family may be, there is a cause and effect connection between the socio-demographic needs and the birth rate. 106 boys are born to every 100 girls. Apart from the classifications of cause and effect connections discussed here, there are also several kinds of epistemological classifications. For instance, causes are subdivided into general, specific and primary, objective and subjective, direct and mediated, universal, particular and individual. Classifications are also based on the number of factors forming a causal connection: simple, composite, single factor, many factor, systemic, non-systemic, and so on. Determinism and indeterminism. Philosophical determinism is a worldview and methodological principle which derives the possibility of cognition, of explanation and prediction of events of both dynamic and probabilistic nature from the fact that everything in the world is interconnected and causally conditioned. Causality is the nucleus of the principle of determinism, but it does not exhaust its entire content. The classical form of determinism in its mechanistic interpretation was the determinism of the French scientist Pierre-Simon de Laplace, who postulated dynamic causal conditioning of one event by another, which implied the possibility of absolutely rigorous prediction. Laplace formulated this principle of mechanistic determinism as follows: if there existed a mind informed at a given moment of all the forces of nature and the points of application of these forces, there would be nothing in the universe that would not be clear to that mind, and the future, just as the past, would present itself before its mental eye. As for dialectical materialism, it considers the categories of cause and effect as dependent on the categories of necessity, chance, and probability. As opposed to the mechanistic approach, dialectics defines determinism as a theory of relative rather than absolute necessity. The principle of dialectical determinism is borne out by the real process of the development of society, in which development always proceeds on the basis of economic necessity, which ultimately forces its way through countless accidents. Indeterminism is a methodological position which rejects the objectiveness of causal connections and the value of causal explanations in science. According to the German philosopher Heinrich Rickert, causal explanation is only valid in the framework of the sciences of nature but is inapplicable to the social sciences. The human will, just as divine will in theology, is perceived by indeterminism as an autonomous power free in its manifestations from any causality or necessity, as absolutely unconditioned by anything. Indeterminists interpret the principle of objective necessity as fatalism, making no distinction between mechanistic and dialectical determinism, between absolute and relative necessity. The latter, however, far from being alien to the freedom of will, presupposes its presence in human activity, for only on the basis of such free will is it possible to cognize necessity and to act in accordance with necessity. In the sciences of nature, one of the latest surges of indeterminism was linked with the development of quantum mechanics whose laws are manifested in statistical, probabilistic, form. The phenomena of the microcosm, in particular the electron, were ascribed the freedom of will, which was said to enable it to choose some type of behavior regardless of any objective necessity. The impossibility of single-valued predictions concerning the processes of the microcosm, their probabilistic nature, and the statistical character of quantum laws are not evidence of the indeterminism of the microcosm, however, but of the existence of different, dynamic and statistical, modes of manifestation of causal connections. Despite the close affinity of these principles, causality and determinism are not identical, for the latter covers not only the category of cause but also the categories of absolute and relative necessity, chance and probability. The sphere of determinism is further extended when systems relations are included in it. Objective goal-directedness. Determinism is opposed not only to indeterminism but also to various forms of teleology, fr. G.K. Teleos, one who has achieved a goal plus logos, the theory of a special, objective-oriented type of causality, a theory that is either a counterpart of determinism or a supplement to it. observing the rational organization of plants and animals amazingly adapted to the conditions of their existence, and the harmony of the celestial spheres, men asked, already in early antiquity, this question: where does all this harmonious organization of all that is spring from? In answering this question, philosophers relied on different principles of explanation of this phenomenon. Those who held teleological views assumed that the rationality and perfection of all that exists is determined by the initial goal-directedness of nature, which contains, in the depth of its essence, expectations and intentions, and is full of hidden meaning. The idea of teleology only emerges when a spontaneously acting cause is regarded as a consciously acting cause, as a cause acting in an intentionally chosen direction, that is to say, as an objective related cause, or goal. The view that the universe as a whole realizes a certain design cannot be proved empirically. The fact is that a goal presupposes the existence of someone who sets the goal. Teleology leads to theology, in which the rationality of the world is explained by the Creator's original design. Teleologists thrive on the belief that we are the hub of the universe, that everything else in the world is meant for us only. A causal explanation answers the question why a certain phenomenon of nature came into being. To this, teleologists oppose their fantasies as to what it emerged for. In the past, a brilliant critique of teleology was given by Spinoza. While accepting the fact that the human body was constructed on teleological lines, he said it was no good marveling at this fact, as a fool would. It was necessary to look for the true causes of wonders, and to look at natural things with a scientist's eyes. That was the way Darwin acted, as he discovered the natural mechanism of the emergence of the remarkable adaptedness of organisms to the conditions of their existence. His theory of natural selection showed that beautiful flowers did not exist to please our aesthetic sense, or to prove the elegance of the aesthetic taste of the Almighty, but as a form of adaptation to the environment, ensuring a smooth running of the process of pollination. Changes in the animal and vegetable worlds emerge in their interaction with the environment. If these changes prove to be useful for the organism, if they help it to adapt to the environment and to survive, they are preserved in the process of natural selection, consolidated in heredity, and transmitted from generation to generation, shaping the organism's structure to suit its purpose, adapting it to the environment, of which the results so strike our imagination. Bright-colored flowers attract insects, and the insects take part in the pollination. The bright red feathers of cockbirds develop through natural selection. Adaptation is never absolute, it is always relative, and is transformed into its opposite when the conditions change radically. Thus what we have here is selection without any selecting agent, automatic, blind and ruthless, working tirelessly, without any interruptions over countless ages. Selection of anything whatever, striking external forms, colors, the smallest details of inner structure, on one single condition: usefulness to the organism. It is natural selection that is the cause of the perfection of the organic world, of the objective suitability of natural objects to their purpose. Time and death are the only regulators of the harmony of nature. However, some elements of teleological conceptions have objective significance. A conscious goal is one of the principal attributes, only not in natural processes but in human activity. Besides, the so-called teleological approach, that is subordination of the process of research to its goal, or the final stage, has some currency in science. Causality and development. A special range of problems arises in the consideration of the relationship between determinism and the principle of development. Because of its basic orientation, mechanistic determinism could not demonstrate the causal character of development, since single-valued, rigid determination presupposes the existence of a consequence in the cause itself, so that development as emergence of new forms either goes beyond the framework of determinism or is entirely rejected. Thus Bergson asserted that that which is predetermined is potentially accomplished. According to Bergson, the emergence of new forms is made possible by a volitional impulse on the part of the creative element isolated from causally existing nature, and not by objective causal relations. This negation of interconnection between determination and development, and definition of development as a result of a volitional impulse, clearly manifests the teleological tendency, The volitional impulse as the source of development is ascribed goal-directed intention. The inability of mechanistic determinism to combine its basic tenets with the principle of development also stands out clearly in the conception of the causality circle to the effect that time and duration are forms of the eternal return of things, Buddhism, Nietzsche. This position consciously rejects development as emergence of the new, so that time loses its principal attributes, irreversibility and direction. From the dialectical materialist positions, determination in the chain of temporal events is a process which presupposes qualitative development. The motion of matter does not mean monotonous repetition of forms given once and for all, that would be tantamount to negation of the development principle. In its form and content, a consequence cannot be absolutely identical with its cause. Causation is generation, and thus an element in the process of development which participates in the emergence of the new. This complex interconnection is most clearly manifested in social development. On the one hand, its progressive tendency has the form of necessity and is causally conditioned, and on the other, at each stage we have to deal with the emergence of qualitatively new forms, a process in which man's creative, goal-directed activity plays a considerable role. The creative potential of the cause and effect connection also expands the statistical probabilistic mode of its manifestation, in which the genetic aspect of causation, the aspect of generation, stands out most clearly. Thus the principles of universal connection and development are specified in the concept of causality and in the theory of determinism. Before we deduce the category of law, the generalizing category which dialectically absorbs all these fundamental principles of dialectics, we must discuss yet another philosophical principle, the systems principle. 4. The systems principle: system, element, structure. Although causality is one of the basic kinds of connection, it does not exhaust the entire diversity of interactions in reality. The genetic and temporal principle of causality does not cover all kinds of correlative, spatial and functional connections. These connections are united by the methodological systems principle. Before tackling the essence and the methodological role of this principle, let us consider in brief its basic concepts. As distinct from the principle of causality, in which the most prominent elements are mutability and genetic dependence of one phenomenon on another, the system's approach is primarily associated with stability and harmonious correspondence in the phenomena of reality. A system is an integral whole internally organized on the basis of some principle, in which all elements are so closely interconnected that they form a single entity in relation to the environment and to other systems. An element of a system is a minimal unit forming part of the given whole and performing a certain function in it. Systems may be simple or complex. A complex system is one in which the elements themselves act as systems. A living organism, a cybernetic device, a social structure, a scientific theory, the universe, the atom are all examples of systems. Each phenomenon is included in one system or another, but it is not every aggregate of phenomena that makes up a system. The nature of the connection between the elements of a system is embodied in the concept of structure. A structure is a mutually conditioned ensemble of connections between elements within a system which determines the system's qualitative specificity. Consideration of a structure together with its substratum defines the concrete quality of a system, thus we speak of the solar system, not solar structure. Structure and function. Part and whole. A function is the role which an element plays in a whole, both to combine elements in an integral system and to ensure the smooth functioning of the system. Structure and function condition each other. For instance, the structure of the organs of the body is connected with their functions, and any breakdown in the structure, or deformation of the organ, result in the disturbance of its functions. Changes in the development of organs begin with the restructuring of the functions of the organisms under the impact of the changing conditions of the environment, while the structure may remain for the time being without essential change. However, a change in the activity of organs leads sooner or later to changes in their structure. Functional disturbances in organs precede their morphological distortions. The contradiction between the new mode of an organism's life activity and its old structure is resolved through changes in the latter. The resolution of this contradiction is subject to the dialectics of the relationship between form and content, where form is interpreted as structure. But structure is deeper than form. It represents the finest interconnection between the elements of the system in question, the modes of this connection. It is in these modes rather than in the elements that content lies. There is an apt saying that even when a bird just walks about, you can see that it can fly. It is obvious from the streamlined body, suitable for cleaving the air, from the lightweight and fine texture of the bone system, the presence and form of the wings. A bird's appearance is an objectified idea of flight. And if you consider a bright-colored butterfly, you will readily notice the semblance to a fluttering flower. The butterfly feeds on nectar, and the likeness to a flower protects it against birds, as it sits motionlessly on the cup of a flower. The life of a bird is connected with air, the life of a butterfly is connected with flowers, and that determines their structure. The logic of systems thought is largely similar to the dialectics of part and whole, familiar since the times of Plato, in which a whole is interpreted as something both unified and divided. Genetic causality and systems correlation. The relationship between the elements of a system is characterized by the type of interaction which presupposes simultaneity of their existence, otherwise the system as such would disintegrate into isolated processes and phenomena. That is the fundamental difference of systems relations from genetic causality, which necessarily implies relations of temporal sequence. Causality and the systems principle cover most of the types of connections now known. Coexistence and causal connection are the principal forms of connection and interdependence. The principal kind of systems relations is correlation, that is the correspondence connection. Not one element of a system can change without affecting some change in the system as a whole. The structure of any system relies on correlative connections. Harmoniously correlative, coordinated actions of elements are a necessary condition of the system's existence. Darwin, who established the law of correlative change of an organism's organs in the course of the biological evolution, believed that it wasn't often that one could say which of the two correlative parts changes first and causes a change in the other, or whether that change was the result of some common cause. Particular manifestations of the correlative connection are coordination and subordination, as well as all kinds of functional dependences. The relation between the system's principle and the principle of development. The orientation of the system's approach at correlative connections does not mean that the system's principle is incompatible with the principle of development. Each system, as an ensemble of correlated elements, is in the process of constant functioning and change, and that process does not cover the system as a whole but also its separate elements. The distinctive feature of a system's object is that, passing through a series of qualitatively different states succeeding one another, a system remains identical to itself, with the exception of cases of disintegration. Thus concrete elements of the biological structures of a living organism are periodically completely renewed, but the organism itself remains invariant. Consideration of systems relations outside a temporal perspective is only possible as an abstraction, for any system is first and foremost a functioning system, and functioning is the system's motion through time. The most stable element of a system functioning in time is its structure, but the latter is not absolutely invariable either. A structure does not emerge spontaneously. The origin of structures is subject to the principle of causality, and their existence and functioning, to the system's principle. For instance, the process of chemical combination of oxygen and hydrogen is subject to the causal principle, which is active in the production of a structure, say, of a water molecule, but the subsequent life of this molecule as a system is regulated by correlative rather than causal laws. The structure of the process of development itself is a special sphere of joint manifestation of the system's approach and the principle of development. The sum total of changes appearing as a result of the system's development form its new qualitative definiteness, characterized by a structural organization of its own. However, the new structural organization, especially in a living organism, does not mean a complete disappearance of the old one. The latter is preserved as a definite structure in which information about a definite level, stage, of the system's development is recorded. The structural level of the organization of a system considered in its static aspect, always contains information about its past dynamic state. Thus the genesis of the psychical structure of a mature personality has several stages at each of which psychical units previously unknown in the given individual take shape. All these stage-related structures are retained and exist as levels or elements of the personality's psychical system as a whole. That is why the static structure of a system may be regarded as a spatial projection of those temporal stages through which the given system passed in its evolution. In this sense, structure is not only the law of the system's organization but also of its functioning. The formation of a structure in time, that is the process of its molding and functioning, is therefore one of the most essential characteristics of development. Structure formation is subject to definite periodical or cyclical laws referred to as the rhythm of development. Rhythm as a manifestation of periodicity expresses the stable in the dynamic. There is rhythm, for instance, of the Earth's geological processes, as expressed in the cycles of mountains formation, now intensifying, now abating. Biological processes too are rhythmical, hence the biorhythm concept, as are informational processes, in which, in the absence of rhythm, the possibility itself of information transmission is destroyed. For instance, natural speech is subject to strict phonetic regularities. Failure to observe correct stresses, pauses and syllabic patterns makes speech recognition impossible. Affinity between the rhythms of various processes is indicative of the affinity of the processes themselves. Changes in the rhythm of a process signify a change in the qualitative definiteness of the functioning system. For example, changes in the frequency of the electromagnetic radiation coming from man's various organs indicate malfunctioning in these organs. The causal and the systems approaches complement each other. Their combination provides a deeper picture of the universal connectedness of all phenomena and of their development. Correlation does not produce a new phenomenon but determines in a particular fashion both the state of a system and its functional development. Science today faces the task of adequate combination of the two approaches in the framework of the broader interpretation of the philosophical principle of determinism. Previously, it was mostly based on genetic causal links, while now the system's correlation too is often interpreted as a kind of determination, that is of mutual conditioning of phenomena. Now, what is the difference in the determinist nature of these two approaches? As distinct from causal connections, systems correlation is manifested, in the static view of the system, as determination by the present, synchronic determination, rather than by the past. But consideration of the diachronic, developmental, rather than synchronic aspects of structure formation will reveal the same type of determination as in the principle of causality, the temporal one. Synchronic determination has a wide range of application not only in the consideration of the inner aspects of the system but also in the analysis of its interactions, for example, of the interactions of living organisms with their habitat, where the process of rhythmical adjustment to the environment is particularly important. Metaphysical interpretations of the systems approach. The systems approach has achieved special prominence in recent decades. The enthusiasts who have played such a significant role in the deepening of the understanding of the essence of systems and of the heuristic role of the systems approach have also been guilty, however, of exaggerating the importance of this approach, which was at times presented as a new and global trend in scientific thought, despite the fact that its sources lay in the ancient dialectics of part and whole. The systems principle is a fundamental feature of the dialectical method. The metaphysical lifting of the systems approach to an absolute followed this pattern. The first variant of this approach was the proposition that the world is desubstantialized. This is a variety of matrism, which asserted once that matter disappeared, with corresponding emphasis on the structural elements of being devoid of their concrete material carrier. This proposition is based on the idea that, since it is the structure of a system rather than system itself, with its material carrier, that is the stable element in the process of the system's change, underlying the world is a desubstantialized structure as pure relation. But the development of concrete sciences applying the systems approach refuted this idea. Thus the formula language is a system of pure relations proclaimed by linguists at the beginning of this century merely led to superfluous mathematicization of language and ultimately to linguistics becoming a system of constructs in which the new results obtained were, in fact, a clarification and deepening of the logical operations of thought. But, as soon as the need arose for creating artificial languages for communication with computers, mathematical calculations lost their definiteness at once, and linguistics turned again to the living flesh of language, to its sound matter. Thus we see that structure taken without its substantial filling, both in the sense of matter and energy, is a logical concept rather than an independently existing object. In the second version, the emphasis is on static and immutable, that is to say, actually given a priori, structural schemata, especially in thought. From this standpoint, underlying cultural evolution is a sort of fundamental code consisting of an immutable set of structural archetypes, codes and elements, manifested in reality in extremely diverse forms but devoid of any development. Apart from partial revival of Kantian a priorism and metaphysical coloring, the positions of philosophical structuralism also show distinct traces of idealist tendencies, since a priori structures stand here for the ideal first principle of the world, while the idea of development is ousted by the idea of reproducing of archetypal structures. It is a well-known fact, however, that the source of development, of the emergence of new forms, including new structures, is material interaction and reciprocal conditioning of concrete phenomena, which must have material, in terms of substance and energy, form for this interaction to occur. Pure structures cannot interact, they lack the necessary fulcrum. The common features of these versions of the metaphysical treatment of the systems approaches an absolute is rejection of the principle of causal determination and elevation of systems correlations, devoid, at that, of material implementation, to the rank of a fundamental property of being. In dialectical materialism, however, the systems approach, along with the principle of causality, is only one constituent element of its methodology. In dialectics, the stability of a structure is not opposed to its development but forms an organic unity with it. From these positions, structure is conceived not as a goal previously specified and marked for material implementation. Teleology is yet another consequence which follows from the philosophy of structuralism, but as a result of material becoming itself. Without matter, structure is devoid of the attribute of development and becomes a purely logical construct. It can be said that the system's approach specifies that aspect of the principles of universal connection and development which is not exhausted by the causal approach. Taken together, both these approaches make up the content of philosophical determinism in its broader interpretation, combining various forms of the conditioning of phenomena underlying the process of development. The dialectical category of law is the node at which all the principles described in this chapter come together. 5. Law and regularity. The concept of law. Practical experience constantly demonstrates that the processes going on in the world are not a chaos of raging elemental forces. The universe has a code of laws of its own. Everywhere we observe order coextensive with the world, the planets move along their strictly determined paths. However long a night may be, day will inevitably come. The young grow old and depart this life with implacable necessity, and a new generation is born to replace the older one. A watermelon or strawberries cannot grow out of an acorn, neither does time flow in reverse, winter never follows spring. Everything in the world, beginning with the motion of physical fields, elementary particles, atoms, crystals, and ending with giant cosmic systems, social events and the realm of the spirit, is subject to regularity. Century after century man noted the strictly determined order of the universe and recurrence of various phenomena. All this suggested the idea of the existence of something law-governed. The concept of law is a product of mature thought. It took shape at a late stage in the formation of society, at a time when science evolved as a system of knowledge. A law is an essential, stable, regular and necessary type of connection between phenomena considered in a generalized form and adjusted to the typologically classified conditions of its manifestation. Laws as relations of essence or between essences are guarantees of the world's stability, harmony, and at the same time its development. Being in their form, or formulation, the products of human knowledge, in their inner content laws express objective processes of reality. The study of laws is the principal task of science. Scientists are constantly searching for regularity, order, stable tendencies in phenomena, that is, for law-governed connections. Man's power over nature and history is measured by the extent and depth of his knowledge and ability to use their laws. Law and philosophical determinism. The concept of law is closely linked with the notion of determinism in the broader acceptation of the term, but it is not identical with it. Determinism covers the universal conditions of phenomena, while the concept of law expresses the qualitative stability of recurrent connections, evaluating them in terms of their objective necessity and qualitative regularity rather than in causal, or systemic, terms. Reflecting the regularity and necessity of a connection, a law as such is not a determination but merely a measure of stability, and therefore of recurrence, of such determination. The concept of law may precede rather than follow causal explanations. Thus event A is interpreted as a cause of event only in the sphere of the action of a definite set of laws of nature that we already know. It is only possible to deduce event A from the subsequent event if the regularity and necessity of such a connection has already been established by a law. A law is thus not just a measure of the qualitative stability of a connection but also a measure of its predictability. A law as an expression of the action of objective necessity and as a measure of predictability of events can therefore also be regarded as a special type of determination, as determination by the future as distinct from the causal determination by the past and systemic, correlative determination by the present. But that does not at all mean that formulations of laws must be causal. Recall all the mathematical formulas reflecting the laws of quantitative changes in nature. Does Einstein's formula correlating mass and velocity have the form of a causal connection? It does not. In the absolute majority of cases, laws are formulated as functional dependences or classificatory correlations, that is to say, the form of expression of a law ultimately gravitates towards a system's correlation rather than genetic causality. Even the laws of causality are expressed as functional correlations. But that does not mean that causality is absent in relations reflected in correlative formulations of laws. We have here a dialectical contradiction, which has confused many minds that saw it only as a formal contradiction. On the one hand, the content of the category of law took shape in keeping with the law of causality, and on the other, laws were always formulated as various functional correlations without any causal substantiation whatever. This apparent paradox at one time, namely in periods that were critical to the principle of determinism, for example, at the time of rapid development of quantum physics, when indeterminism found favor among many, gave rise to controversy over the category of law. It was debated what the status of laws was, and whether they were immanent to the world or thrust on it by some external, and probably ideal, force. According to religious idealist views, everything in the world follows the path predetermined by God, everything obeys the will of the Almighty. A tendency existed, and exists even now, of identifying the laws of the world with God. The world is governed by God and the laws, or else God runs the world through laws. Laws are thus personified and likened to the reasonable and order-creating power of God. From the standpoint of objective idealism, natural processes are subject to definite laws constituting reasonable non-material relations, and from the standpoint of subjective idealism, the laws of science emerged only out of the human mind's love for and habit of orderliness. However, because the world is matter in motion, has the properties of self-motion and self-development, of infinity in space and time, that is to say, because the world is a self-governing system, its laws represent its inner, immanent self-government. The concept of law emerges as a dialectical combination of the principle of universal connection between phenomena, in its causal and systemic forms, and of the principle of development, which we had already considered not only from the angle of explaining past events but also from that of prediction, however relative, of future states. Laws help to understand both the connection between phenomena and the mechanism of the formation of the new, which is an attribute of the constantly developing and continually enriched world. Classification of laws. Law and regularity. According to the sphere of the application, laws are divided into universal, for example, the law of conservation of energy, or the dialectical laws which we shall discuss below, and particular ones, valid only in a limited area, as for example the laws of social development, which are only manifested at the level of the social form of the motion of matter. When the conditions under which laws are valid change qualitatively rather than quantitatively, the laws operate in the new situation in the same way in which they operated in the previous situation. Of course, there are no laws that would be absolutely independent of any conditions. The wider the range of conditions under which a law is valid, the more general that law is. According to their inner content, laws are divided into the laws of the structure. These are mostly laws expressing the necessary correlative connections in systems, the laws of functioning, the joint area of causal and systemic determination, and the laws of development, the area of primarily causal determination, which has both explanatory and predictive value. The dialectics of necessity and chance imparts to the laws of development the character of tendencies which force their way through a chaos of unpredictable chance occurrences. Recall the progressive and regressive tendencies in social development. In their form of manifestation, laws, just as the kinds of causality, are divided into dynamic and statistical or probabilistic. Thus a stone thrown upwards will inevitably return to earth according to the law of gravitation which acts dynamically, that is without any indeterminacy, whereas it is impossible to predict the number of points in a throw of dice, since this kind of event is only described statistically. The concepts of tendency and statistical probability must be strictly distinguished. A tendency reflects the intricate path of the manifestation of dynamic laws, which will pave the way, in one way or another, for its strictly determined consequence through a chaos of chance occurrences, while statistical laws presuppose an alternative, at least two-valued, probability of a concrete event. In this last case, a law is not manifested as an obligatory occurrence of the given particular event A but as a statistical quantitative regularity governing the occurrence of equally possible events A and B. This difference between the dynamic and statistical modes of the manifestation of necessity is often used as a reason to oppose the concepts of law and regularity. The term law is applied to dynamic manifestations or tendencies, and the term regularity, to statistical ones. However, it would be wrong to completely oppose the concepts of law and regularity. Both of them are different expressions of necessity, but regularity, unlike law, reflects a certain degree of probability of the necessity rather than its rigid determination. Thus the structure of any organism or, say, the composition of a work of art are subject to biological and aesthetic laws respectively, but an organism, and still more a work of art, also have a great many qualities that individualize them, which are, in terms of the general law, an aggregate of chance occurrences through which the law is manifested, or jointly with which the law acts. Acting in a mediated fashion through chance occurrences, a law's necessity in the concrete relates to this concrete as a regularity. In other words, a regularity is a law in the precious setting of chance occurrences, a form of concrete manifestation of the law. The world is governed by laws, and not by a blind, implacable fate. The probability of laws, their action in conjunction with a train of chance occurrences make for the bright colors and wealth of life which is not subject to any schematic dogmas. This is particularly true of the higher levels of the organization of matter, in the first place for the social form of motion, for the laws of social development cannot be implemented without the activity of people possessing a sufficiently high degree of creative freedom. Thus everything in the world is interconnected, which gives an active impulse towards the world's self-development. The self-motion of matter is impossible without connections. Development is impossible without self-motion. Development is conditioned by various kinds of connection, and the most important of these are causal generation and systems correlation. The highest manifestation of the synthesis of the principles of universal connection and development is the category of law, a category which does not only explain the past but also partially predicts the future. Man occupies a special place in this process. Unlike the unconsciously acting laws of nature, he consciously realizes the concealed potential of social laws, impregnating them with his creative energy. Chapter 6: The Basic Categories and Laws of Dialectics. 1. On the unity of indifferences between the categories and laws of dialectics, categories as stages and forms of the knowledge of the world. The world in its constant motion and development is reflected in thought that is just as dynamic. If everything develops, wrote Lenin, does not that apply also to the most general concepts and categories of thought? If not, it means that thinking is not connected with being. If it does, it means that there is a dialectics of concepts and a dialectics of cognition which has objective significance. 1. The content of categories and laws and their interrelation contains precisely this kind of dialectics of cognition. Even the simplest thought like 3 yellow leaves fell to the ground contains such concepts as object, leaf, the ground, quality, yellow, quantity, 3, motion, to fall. If in perceiving things we do not place them under the headings of some concepts or categories, we are doomed to mindless observation of objects. The categorical structure of thought is a necessary premise of the cognitive act. To every person starting out in life, the historically established categories are given as something a priori or pre-experiential in relation precisely to that person, although they are a posteriori or post-experiential in their origin. As they are assimilated, the categories determine the area and orientation of the vision of any form of givenness, natural, social or spiritual. They direct the substantive understanding of the world by man and of man in the world, and impart a structure to cognitive activity, determining both the field of the mentally observed reality and the angle of its interpretation. In other words, the categories are filled both with methodological and worldview content. Thus the